Our attention is often easily seized by the latest shiny thing, which in the world of lighting happens quite regularly. LEDs, sensors, PoE, human-centric lighting, you get the idea. But it bears remembering and reviewing the fundamentals of what makes a lighting scheme good. Welcome to the session, Lighting Quality, Getting Back to Basics with Linda Conejo, National Accounts Business Development Manager in Canada for Ledvance. Linda joins EBPowerCon to walk us through some fundamental tenets of lighting. She'll explain what light is and how we perceive both it and color. She'll get into CCT and CRI, IP and IK, and so much more, all of which will help you on your next lighting design or retrofit. Linda, thanks for joining me here at EB PowerCon, and I'm really looking forward to this session because lots of people, and ourselves included, Electrical Business Magazine, we like to talk about the newest, the coolest, the greatest. You and I spoke last year about human-centric lighting and where that's going. People talk about connectivity, IoT lighting, all this other stuff. But I think a session like this is really warranted to actually just get back to the basics of lighting. Maybe we just still need to focus on getting the lighting right for our application. So I appreciate you coming on to actually sort of instruct us in that.
Thank you very much, Anthony. It's a great pleasure to be here and EB PowerCom. It is something we tend to forget. Is getting back to basics, lighting quality. The everyday things that we take for granted. The basic question: what is light? In general terms, light is radiant energy that enables us to see. Because there are many types of lighting, as you know, X-rays, ultraviolet lighting, microwaves. We don't see any of those things. Right here in the middle is where the human eye can see, right between around 500 and 600 nanometers. So that is where we see light. Light itself cannot be seen directly. Light is reflected or transmitted. As you see in the picture, you see a fixture with a metal halide light inside there, and the light would be reflecting off the lens out into whatever it's lighting. For example, this could be an arena or a sports field. And then after that light is reflected, the eye receives that image. And then the brain interprets that image. If you take a look back at the long and varied history of light and light sources, it's easy to see just how far we've come with light source technology. In 1879, Thomas Edison patented the carbon filament vacuum incandescent light. And now, if you ask some people in the electrical distributor world, or even homeowners, they don't even think about any other technology besides LED, because LED has dominated the market for the last, but it's a very short time, probably 10, 15 years. It's really started to come on board for general lighting applications. So there are many lighting terms that many people don't understand when they're looking at lighting. Luminous flux, or lumens, that's how it's measured, is the quantity of energy of the light emitted per second in all directions. So that's the technical term. So the unit of luminous flux is a lumen. So when you're looking at a light bulb or a fixture, it will reference the lumen output of such fixture. So that is the amount of light that is coming out of it. So definitely something that you need to understand. And when you're doing a lighting design, you have to look at, and there's a lot of different things that you have to think about: the height, the spacing, the space, the colors on the walls, but we'll get to that a little bit later. Another lighting term that you need to think about is illuminance. Okay, so illuminance is the amount of light striking a surface, also known as incident light, where the incident is the beam of light actually landing on the surface. That tells you, so if you're designing an office, you want to know how much light is on a desk. So that's your illuminance value. So that will be in foot candles or lux. Reflectance is another term that you need to think about. So that is usually a term in a percentage. So reflectance, it's exactly what it sounds like. It's the amount of light that will be reflected off the surface. So for example, if an office has black desks, you're going to have 0% reflectance because all the light is going to be absorbed into that black desk. But if you have a white desk, that will definitely brighten up the space because you will get some light coming off of that. So just something to think about. Luminous intensity. Okay, the luminous intensity is a measure of the wavelength weighted power emitted by a light source in a particular direction per unit solid angle based on the luminosity function and standardized model of the sensitivity of the human eye. That's not something the average person really talks about, but it is a term that you'll hear in that context when you're talking about lighting. Luminous excitance, so that's the amount of lumens per square feet or lumens per square meter. That's the light that's reflected off, right? So as I said, if you have a black desk, you're not going to get any luminance excitance. You'll only get absorbent. So just keep that in mind. And then luminance, and that's usually in candelas per square meter. Again, candela is not something the average person talks about. We talk more, you'll hear the terms lumens, foot candles, lux, reflectance or excitance a lot more than you'll hear the luminance and luminous intensity. So now, what is correlated color temperature and color rendering index? Those are two terms that people talk about as well in the lighting world. If you were to look at a candle, candle light would be very warm. You see that golden glow. So in a correlated color temperature, or CCT as we call it, it would be in that warm color range. So 1900 Kelvin. So the temperature is calculated in degrees Kelvin. I know a lot of cities have changed to LED streetlights, but there's still a lot of cities that don't. I know Toronto still actually has a lot of metal halide lighting, so that would be more in the cool range. In some cases, it will also be in that warm range, probably around 2,700 or 3,000. But some older neighborhoods you'll go into, you'll see kind of like this orangey glow, which is high pressure sodium. That's around the 2,200 Kelvin, so very warm. It is the best kind of warm color temperature is the best for trying not to disturb nature. Everything from bugs to birds to people. So it's something to think about. So a lot of designers are looking at the more warm colors, so around the 2,700, 3,000 Kelvin for outdoor lighting. In the office areas, you tend to see, 3,500 Kelvin, which is kind of like a in-between color, 4,000 color temperature. And then you'll get into more specialty lighting where it's much higher, much bluer. So the easiest way to know is the warmer color temperatures they have more yellow in them. The higher color temperatures have more blue in them. And I'll show you some examples. in these slides that I'm showing you here is it's the exact same image. Okay, so it's a bunch of shirts and ties, and the difference between a 2700 Kelvin light source to a 6500 Kelvin light source. If you look, everything looks, the colors look completely different. And I think that's where a lot of people don't realize that, you know, people go to the store. I mean, I'm sure people have gone to the store, they've bought a suit or a dress or a shirt, and in the store it looks one color. You get outside, it looks a different color. You bring it into your house, it looks like a completely different color. And that's because there is different light sources at each of those places and with different color temperatures. So it's something to consider in your home, in your offices, in any space that has artificial light. This again, this is color rendering index. Okay, so if you take a look at the color rendering index, again, it ranges from 0 to 100, 100 being the best, most natural lighting available. I know with LED, there's some different terms that they take a look at, but we're just going to stick with the simplest CRI, color rendering index. So on this slide, you can see that with a poor CRI, these colors that have, you know, these 9 different colors, it kind of all looks like a bunch of browns and oranges. Okay, so that is kind of like high pressure sodium, or even probably closer to low pressure sodium, which I don't know many places that still use it, but it did definitely have a very poor color rendering index. Then you go to the high pressure sodium, which is still that orangey light that you see in some neighborhoods. And yeah, you can kind of see what the colors are, but some of them they kind of look off. So, you know, for reporting, oh, there's some car sitting on my street for the last 3 nights, and they ask you what color it is. If you have that high pressure sodium, you may say it's a gray, but really it could be a blue because the color rendering index is just not there. And I'll explain how that works. You know, when you look at color rendering index of 70 or above, we typically say that is very good. You'll be able to see what the color is. The IESNA calls color rendering index the measure of the degree of color shift objects undergo when illuminated by the light source as compared with the color of those same objects when illuminated by a reference source of comparable color temperature. As you can see, these 3 tissue boxes have a flower on each side. Color rendering index, as I mentioned before, is 0 to 100. So the closer you are to that 100, which is daylight, the more natural the color will look. So the higher the color rendering index, the more vibrant the colors are that you're looking at. Again, here's another good example of CRI. A low CRI of the picture of fruit, and then a high CRI picture of fruit. Which one looks more appetizing? So as I alluded to before, the observation of color is very important. So in order to see a color in any environment, okay, the source of light must produce and the object must reflect that color. So an incandescent bulb, there's not a lot of blue. So the blue may look a little duller with an incandescent light than it would with a light source that has more blue in it. Noonday sun, that is the ultimate. It has every color available in it. So that's why in natural sunlight, you can see all the colors. You can see the blues. You can see the reds. It's vivid. It's clean. If I show you the spectral power distribution curves for other light sources, you could see that some of the light sources are missing good pumps of certain color. So for example, the first one is a daylight version. So you could see it's very evenly spread across all colors. So you'll see greens and blues and purples and reds and all the colors of the rainbow, as I said. With tungsten halogen or incandescence, there's a lot of reds and yellows in it. So you may not see the blues as well as you would with a different light source. Fluorescent bulbs, they manage it with the triphosphor. So what they do is they put a little bit of everything in it. But as you can see in the chart, it's a little low on the red. So you may not see reds as well with a mercury fluorescent type product. Metal halide, this is like a ceramic metal halide, 3000 Kelvin, low on the blue, very big on the green and the yellow, and higher on the red. So again, you may not see the blues as well or as vividly. And then high pressure sodium, and then that low pressure sodium. It only has one color in it. It has yellow. Let's say a community had low pressure sodium lights on their street lights, and people were driving around with cars and everything. It would be very difficult to know what color each car was. Lighting design, because lighting design is very important in the whole lighting process. Lighting design is the creative process for developing lighting solutions for the safe, productive, and enjoyable use of the built environment. So what does that mean? You have to take everything into account when you're doing a lighting design. You need to understand the needs of the client. You need to understand their expectations and their budget. You need to gather the project job information of the space. What colors are they going to paint the walls? Are they going to have a black ceiling? Are they going to have an open ceiling? Obviously you have to look at electrical codes, very important, ASHRAE, things like that. You have to select the lighting levels. You have to understand what lighting levels the customer needs. Or, if someone is working in a lab, they will need a lot higher light levels than someone working at a desk all day. We do have the IES handbook, so that can give you some recommendations for the quantity of light that you need. Plans, diagrams, schedules, project management of the whole thing. Post-occupancy, that's really important, especially when you're doing controls and things like that. And one thing that people tend to forget is you really need to think about how easy or difficult it will be to maintain that lighting. There's been many projects where I've been to that beautiful design. It's wonderful, but after the fact, the people on the ground, they can't maintain the lighting. It's either too high, you have to build scaffolding, you need to bring a special boom. And then what ends up happening is that lighting ends up just failing, and then they don't even keep it up. Layers of light is really important in the lighting design process. There's ambient light, accent light, task lighting, and decorative lighting. So ambient light, if you look at the picture, is the general light. If, for an example, in this picture here, the ambient light would be the pot lights in this top picture here. Accent lighting would be the lighting that's highlighting the different paintings or the artwork along the walls. Task lighting could be at your desk. And then, of course, decorative lighting. Something that's visually inspiring. You can see a beautiful chandelier in a ballroom. Lots of lighting techniques. There's down lighting, diffuse lighting, up lighting, valence cove. These are just some examples here in these pictures. Along the wall, you can see a nice wall washing of the wall. You can see up here in the top right-hand corner, it's a valence lighting. So there's no direct lighting going down to the bed. It's lighting up the ceiling to give a lighting effect. And then in this office, this is an example of uplighting, or where the light is, some light is coming down, but some of it's reflected off the ceiling down as well. So another way to light a space. So following the design process promotes safety, comfort, productivity, and energy efficiency. So the importance of the design process, you have to understand the project. You have to make a roadmap, understand all the elements that are needed in the calculations. You need to use tools that are available, programs to build virtual models, and I'll mention that a little bit later. You have to be critical of the results when calculated. You have to say, okay, is this enough light? Is this too much light? Have I included the proper lighting for this space? You know, and that's why it's difficult sometimes when they give you a design and they say, oh yeah, the furniture is going to be this is going to be the colors, and then all of a sudden they change it. Well, that really does change what you need for lighting sometimes, especially when you're talking colors. If you're going from a light color to a dark color, you're going to have to increase light levels because you are losing light levels with the lack of reflectance. And you have to look at the quantity versus quality. You don't want to just put a bunch of light in there and just overlight a space, because that creates problems as well. This is a list of issues that need to be addressed in the initial stages of a lighting design. So again, space function, building materials, room finishes, architectural style, space plan, furniture style, where the art's going to be, where's the sign going to be for the company. You know, if you have a chance, you should talk to the workers. If all the employees are under 25 at this place, they don't need as much light as people that are a bit older, right? So it is something that you have to keep in mind when you're looking at a space as well. You also need to know if they're going to be changing the space and using it for different things. Again, as I mentioned, you know, the age of the occupants, the tasks that are being performed, they're doing very detailed work, you need higher light levels. Are they going to be working 3 shifts if you're talking about an industrial plant? Choose fixtures or luminaires that are low maintenance and easily accessible. Another aspect that you have to look at sometimes is the IP rating. So for example, food industry, farming, dirty environments, some of these type of facilities will need an IP rated fixture. So just to explain, an IP rated fixture, the first number, as you can see in the chart on the left, will tell you the amount of particulates that will go into a fixture. So if an IP rated fixture is 15, well, some things can get into it. But when you're looking at an IP 60 something rated fixture, that means dust and bugs and things like that cannot get into it. The second number highlights water. So if a fixture allows water in it, it will be a lower number than if it doesn't. So for example, an IP 67 fixture will withstand water. So if you're working, let's say in a Perfect example is a food industry, okay, and they wash it down every so often. Well, yes, you can use an IP67 fixture for that type of environment. Another reading or marking that you could look for is an IK marking, which is impact resistance. So the higher the number, the more resistant to impact it is. So for an example of this would be, I actually worked on one not too long ago. It was an arena, and they wanted an IK 8 or higher lens for a fixture, because sometimes a puck will go flying, it'll hit the fixture. They don't want the fixture to break, so they want it to have an impact. So that kind of gives you a little bit more protection for the fixture that you're using. As part of the lighting design process, you should do a lighting layout. Sometimes you'll have a CAD drawing, which is very helpful. And then we can adjust lighting levels in different regions. Here are just a couple of examples that I worked on. And you can see where the intense light is, where the lower levels are, if you have to increase the lighting levels on certain areas. In this project, there had to be higher light levels in one spot over another because they were doing more quality control detailed work. So they needed more light so they can see any imperfections before they let it off the line. These are tools that are available in the market. As I mentioned before, energy codes, you need to look at energy codes too when you're doing lighting design. ASHRAE 90.1 2016. These are all things that need to be thought of when you're doing retrofits as well as new construction. Okay, so you have to implement some controls into your designs. So now I'm just going to show you a couple before and after pictures of some projects that I was involved with one of our electrical distributors. This is a Discovery Ford. It is a Ford dealership, obviously. And the picture on the left shows you the metal halide, the lighting that was there before. And then the picture on the right is the LED product that they installed after the fact. So as you can see, it's the second one is a little further away, but you can see how the light is directed properly. And now you could see the actual spaces. You could see the laneway better. It's a lot brighter, but the great thing about this also is they can dim them down when there's not a lot of people. They can turn them off, or some of them off. So they actually incorporated some controls into their retrofit, as well as improving light levels and creating energy savings at their location. This before and after, it's actually on the arena's website. It was a metal halide arena, very dark. And with metal halide lights, they tend to shift in color as well. So that's why it looks almost green on the left side. And the after picture is with some LED fixtures, some LED, what we call UFO fixtures. Bright space. The people could see everything on the ice surface much better. We actually, in this job, we actually added a bottom lens as well to reduce glare, but the customer is extremely happy with this after retrofit as well.
I should hope so, Linda, because that before photo looks like an arena that came out of a horror movie.
It really does. And I mean, they didn't change any of the ceiling or paint anything. It was extreme. It was extreme. They obviously had some very poor metal halide lights that were at end of life. Um, it's funny. I've been into many facilities where I always tell the person, if you could look right at the metal halide light and not burn your retinas, it means that they're end of life. You need to change them. But a lot of people always go with, well, it's still burning, so why not? But if you've lost 40% of the light output, it's dead. It's time to change. And then I just wanted to include this. Lighting technologies are responsible for 18% of electricity use, and you can see this map. The eastern seaboard is incredibly bright. Some of that could actually probably be controlled a little better. But that is definitely something that needs to be considered. Is we're using up a lot of electricity. Um, if we can change to a more energy efficient product, if you do the lighting correctly, um, it will make a difference in the electricity used in all of North America. So good lighting design can help with that. So please keep that in mind as well.
No, that's a good way to end with that map and showing how much lighting we use, how much electricity it consumes, because it ties into some of the sessions that we've already had at EBPowerCon, looking at net zero energy, getting to net zero emissions, reducing our carbon footprint as much as possible. So, lighting is as good a place as any to start, especially looking at that arena photo from before, which looks like a horror show. I mean, you have a moral obligation to fix that lighting.
Exactly. I can't imagine anyone wanting to play hockey in there.
Now, before we wrap it up, Linda, you had already mentioned actually a couple times where designs have not taken into account maintenance down the road.
Mhm.
Outside of some of the other things that you pointed out in terms of making sure that you know what sort of furniture or furnishings are in a space, what color they are, how the space will be used. But outside of maintenance, can you think of one or two other, let's call them sins of lighting that you still regularly stumble upon, that you need to educate people on, or that people just keep doing wrong?
There's some people that they won't employ a lighting designer or work with someone lighting with lighting experience, a lighting specialist. There's lots of different people. If you're doing a retrofit, sometimes they just want to do a one for one and that's it. um, but you have to keep in mind that some of these designs were originally done in maybe the 60s or 70s, where lighting levels were much higher uh, at those times. So if you're doing a one for one just blindly and not looking at what the lighting levels um, are or can be, you might be doing a disservice to both the customer or to your employees, because there's many times that um, they go from, for example, they'll go from a fluorescent system to an LED fixture one for one because they don't want to change the ceiling tiles or anything. And then what ends up happening is people get headaches, or they're complaining that it's too bright. Those are things you have to consider. So working with a professional is really important, so that you know what the today's codes are, uh, where you can push the limits, get better energy savings, get the best light for the customer, the employees, everybody. That is one thing that I still continue to run into sometimes. And then there's others, is the other extreme. You know, they'll see someone advertise that, oh, this 50 watt LED fixture will replace 1,000-watt metal halide. Well, that's, stretching the truth a little bit. It can if the space was overlit and you don't need that much light, but you still need to look at what the light is existing, what the light level expectations are, and then design it based on those expectations. But, you know, a lot of people think, oh, energy savings, energy savings, energy savings. But if you do too much energy savings and you're not meeting the minimum criteria recommended by the IES, it's just not a good design either. So that's another one. So it's either overlit or underlit. Those are the ones I continuously fall across when I'm working out there in the industry.
Well, and to me, it just makes sense that if you are retrofitting a space and you're moving to a new technology, so you're getting out of your tubes, your fluorescent tubes, and you're going to redo the whole thing. That's probably a great time to actually engage someone with expertise and say, we're going to do this fundamental shift. And perhaps they need to be convinced that it is a shift. It's not just a one-for-one replacement, as you say.
Yeah,
And re-examine it with the tools that we have and with the expertise that we have at our disposal today versus the 1960s or what have you,
yeah,
and light it right. Uh, so,
yes.
so hopefully, people watching this and they'll talk about what they've learned here. They'll pay a little bit more attention to that. If we're going to do it, let's do it right, as opposed to put in the investment, the time, and just not do it right, and it doesn't achieve its fullest potential.
Exactly. Yeah, absolutely.
Linda, thanks again for taking the time. I've learned a lot from this presentation. It's good to have those fundamentals and those basics nailed down as much as possible, so that as you move forward with lighting designs and lighting a space, you have that foundation to fall back on to make sure that you're sort of ticking all the boxes, and you're on your way to hopefully a successful installation. So thanks for coming by.
Thank you so much for the opportunity. I really appreciate it.